This is Dr. Eduardo de Marchena with Aaron Cohen here, and we're continuing the series on valvular heart disease for mechanisms of disease. And today we're going to talk about mitral stenosis. So remember that the aortic valve was a tri-leaflet valve. Well, the mitral valve, as you all know, is a bicuspid valve, and the valve is really if you look at the annulus of the valve, it's actually almost like a D-shaped annulus. And the leaflets of the valve really sit like a little smiley face, or people call it a fish mouth appearance, where the one commissure, the posterior commissure is here, the anterior commissure is much bigger and above the valve. When it opens, it opens widely, so the anterior commissure comes up and the posterior commissure continues to go down. And so it makes a huge hole during diastole to allow for left atrial empty. If we were looking at this in a long axis of the heart, we'll just draw that real quick. So this is the left ventricle and the left atrium. Here would be the aorta. And then this would be the left atrium, this would be the aorta. The aortic valve would sit here. The mitral valve would sit here. And if we finish drawing the heart, we'll put a little color here to make it less boring. Okay, so here now we have the left atrium down here. And if we looked at pressures, the normal left atrial pressure, let's say it's 8. And the left ventricular pressure is 120 over 8. So that means that in diastole, there's absolutely no pressure gradient across the mitral valve because it opens so widely. And the reason that that this happens is because the valve leaflets are very pliable and they move straight up and straight down, allowing a huge central orifice, allowing blood to go through. So this is normal mitral valve anatomy. And so in essence, this is a valve that functions purely on pressure. And so when the pressure in the left ventricle drops low enough, the pressure in the left atrium is higher, and the mitral leaflets just fly open, these nice pliable leaflets, allowing this huge central orifice that allows blood to go into the ventricle. Now, if we were looking at this with pressure tracings, we're going to start first with a left ventricular pressure tracing, which you guys are all familiar with. So this is the left ventricular filling with the atrial kick at the end, and now this is the isobolomic contraction phase of the left ventricle. We have the notch that signifies left atrial, aortic valve closing. Then we have the isobolomic relaxation phase, and then again we have left ventricular filling, and the next A wave with atrial contraction. Now, in the past, we've only looked at the aortic pressure tracings, but now we're going to look at what happens in left atrial pressure tracings. So in the left atrial pressure tracing, if we were going to superimpose it, it would follow ventricular filling with an A wave. Then when the mitral valve closes, which it closes as soon as the as soon as the left ventricular pressure increases past left atrial pressure, which is right here, then you slowly have the V wave, which is the left ventricular filling phase, left atrial filling phase. And then the mitral valve opens when the left ventricular isobolomic relaxation phase causes the pressure to drop below left atrial pressure, and then blood pours back into the left atrium, and it follows the pressure tracing of the ventricle, again with no gradient across either one. So this would be the left atrial V wave, this would be the left atrial A wave, and at this spot, we'll put in a different color, at this spot would occur S1, which would be mitral valve closing. And this would be a silent event. S2, as you know, is up here, which signifies the AB valve closures, both the pulmonic and the aortic valve. And this is S2. Now, this at this point, the mitral valve fully opens. It empties the pressure from the left atrium. The left ventricle slowly fills again. You get atrial contraction, and then the ventricle ejects again. So this is normal pressure tracings in the left atrium and its relationship to the left ventricular pressure. Now, when we start getting pathologies, things change. So remember, we had this nice, normal looking mitral valve, which was my little fish mouth that was so happy. Now, as we get different types of diseases, the most prevalent of which is rheumatic fever, after its initial acute phase, which is really just an inflammatory valvulitis, and it can cause mitral regurgitation and so forth, as it becomes more chronic, the valve becomes inflamed. And as it becomes inflamed, this causes the commissures to fuse. So the valve that could easily open before now becomes very restricted in its capacity to open because the commissures fuse. And again, if we were looking at this in the long phase of the heart, the mitral valve that could open up just like the aortic valve wide open now has difficulty opening because it's fused. And so it leaves a very small central opening for blood flow to go through, and this causes a major gradient across the valve. So we'll continue on the next lecture on the hemodynamic significance of this and what this means to the physical exam of mitral stenosis.